All right, guys. Well, welcome to a night of security. I'm super excited about this meetup. I've been thinking about it for months, reaching out to people, professionals, talking to people about security, talking to people about what they might potentially talk about. I'm Clint Myers. I'm a co-organizer here at Dallas Software Developers. We got a couple co-organizers here as well. Danny Thompson, Eric over here. And a couple of people that aren't present tonight, but for whatever reason. But anyway, we got a great team here, and we do a lot of really cool things like cohorts and these meetups every 2 weeks, networking, talks, all kinds of things that try to provide value to the local development community. We want to shout out our sponsors. First up, AppWrite, a backend as a service, a tool that you could use to build your next app or potentially with your employer or company. We also want to thank Yum Brands for the venue, as always, and AppWrite for the pizza. Tonight, I had a couple of goals, and the goals were, we often serve and support people either just starting out or in the first half of their career. And we know that hiring and stuff is really difficult, right? Things are really competitive. So in providing value to the community, my thought was, how can we expose people who are, developing apps and things like that to tangentially related careers that are building on those development skills and potentially taking them in a slightly different direction. Maybe that gives you insight into other stuff you want to do, or maybe that strengthens your resolve in wanting to be primarily, front end or back end or full stack web developer, whatever you plan to do. But I think it opens up things that you can talk about in interviews. And the other thing is, even if you want to stay a developer, building a niche, and that niche might be security. It might be something else, but essentially, we obviously are inundated with new tech every day. There's always a new JavaScript framework. There's always a new, whatever tool. And I think when we have everybody building, their resumes with kind of the Spring Boot or the .NET or Angular, React, and stuff like that. And in standing out, can you take your resume, in a niche, in a direction that potentially sets you apart from other juniors? And is a solution to that, adding, this cool sprinkle of security stuff to the apps you make? Or maybe you're really passionate about design. It's not a security thing at all. But essentially what I'm saying is my goal tonight was to expose everybody to some really cool security stuff that you maybe could implement in your next app and potentially get you over the finish line to get that first job, because that's one of the major goals that we're trying to accomplish here. That's it for me to talk beginning. So I'm going to introduce our first speaker, Peter Stromquist. Thank you very much.
Okay, I'm going to try to cram about a 30-minute talk into 15 minutes. So buckle up. We're going to talk about passkeys. Raise your hand if you love passwords. All right, we got a couple. All right, still out there. I mean, they're here for a while, but I'm going to kind of maybe introduce some of you, but maybe some of you've already heard of this, a concept called passkeys. The talk is almost everything you ever wanted to know about passkeys, but we're afraid to ask. The longer talk is the one where you get to learn everything. So real quick, we're gonna whirlwind dive into passkeys. Passkeys is part of an open standard called FIDO. So we're gonna learn a little about FIDO in the process. We're gonna learn a little bit about why passkeys and FIDO came to be and sort of the history. Ultimately, what I want to do is at the end, we're gonna walk through a demo, actually do a live demo of a website that uses passkeys. So, and by the way, I work for a company called Hyper. This is not a Hyper pitch at all. I'm going to be learning all this stuff. It's going to be completely independent of what we do, or at least what we sell. So real quick about me. I live in Minnesota, so I actually flew down here to talk to you guys tonight, which is pretty awesome. Excited to be here. I've been in software engineering for 25 plus years. And then eventually I got into identity, which is one of those areas that Clint was talking about. It's a niche area. It's really cool. And then more recently, in the last year, actually, I got into FIDO, which is the passwordless side of this. I do not work for Initech. If anybody has heard of that company before, it's actually a joke. It's from a movie called Office Space, which is what this whole presentation is kind of themed on. So why are passwords an issue? And the main issue here is that hackers, they don't break in, they actually log in today. I think most of us have kind of heard this before, but there's kind of four main ways that they log in. They're either phishing our passwords or our weak MFA methods. They're doing social engineering attacks to obtain our credentials or create new credentials based off of us. They're doing credential stuffing because we all know that people like to reuse passwords across different websites. So they can take all of those billions of passwords out there and try them out. And then they're actually using malware software that's running on our devices to actually steal passwords as we type them. So passkeys, which is what this little symbol kind of represents, was designed from the ground up to address these problems. And we're going to dig into how that works. So speaking of how does FIDO work, let's walk through this. So to understand how FIDO and passkeys work, we have to actually think about how passwords work. So if I'm signing into a server, into a website, I use a password, it's pretty simple. I just present my credentials to the server. It looks to see if the password is the same. And if they match, then I'm authenticated and I'm in, right? Hopefully these websites today aren't actually storing passwords in clear text. They're encrypting them or hashing them with something like bcrypt. That's great, but bcrypt has some of its own challenges. We'll talk about that in a second. So then how does FIDO actually work? Well, when you go and actually register a FIDO account, and by the way, if you don't remember anything about my talk, these next two slides are kind of like the thing to remember, because this is really how all of this stuff actually works. So with FIDO, when you go and register an account, instead of providing a password, you create what's called a public-private key pair. This is something that actually gets generated on your device, on your phone or on your laptop. It's done for you automatically, and usually with a biometric, it's sort of generated that way. The biometric's not part of the passkey, but it's just kind of used to activate it. So you generate your public-private key pair, and then you send the public key to the server with your username. And the only thing that's stored on the server is your public key. Public key is something that anybody can know. That's why it's called a public. The private key stays securely with your device. Okay. So then when you go to authenticate, here's the magic part. When I go, hey, I want to authenticate as Bill at initech.com, what the server does is says, okay, Bill, I'm going to send you a challenge. So all the challenges is just some random text the server's going to remember during the authentication process. And the client takes the private key with the biometric to sort of unlock this, and it takes the challenge and it signs it. All that means is it encrypts the challenge with the private key, sends that signed challenge back to the server. The server goes, okay, signed challenge, I'm going to decrypt you with the public key that I have on the server. And if the challenges match, then it's authenticated. That's how it works. So there's a little bit more to it than that, but the nice thing is, at the end of the day, there was nothing shared between the client and the server. No secret was actually shared. And this is kind of the sort of the underlying principle of FIDO. So now I'm authenticated. One of the things that a lot of people want to know is how is FIDO actually fast? When you go through a FIDO flow, you'll see that you authenticate pretty quickly from a user experience perspective, but there's another reason why it's actually fast. So we talked about bcrypt a few slides ago, where bcrypt requires, basically a way to hash your password and store it. Well, if you have a website that's got millions of users signing in all the time, and all those passwords have to get hashed so they can be compared with what's on the server, that's very CPU intensive. And it requires you to scale out your authentication servers to be able to handle that load. Well, with FIDO, a lot of the encryption, decryption is offloaded to the actual device. And so it's actually orders of magnitude less of a load on the server. So you can scale out. And that's one of the reasons why FIDO is fast. And FIDO actually stands for Fast Identity Online. So from a performance perspective, it's better. Okay, so let's talk a little bit about FIDO Alliance. FIDO Alliance was basically a bunch of smart people that got together about 12 years ago and said, we're done with the passwords, okay? This is causing way too many problems. So you can see there's various companies have gotten involved. This is not just small companies, these are big sort of big players that are trying to solve this password problem. And it kind of all the way led up to about 2016 when something called FIDO 2 was released. FIDO 2 is what we're really going to be talking about mostly tonight. By the way, the company I work for was actually formed in 2014, about 10 years ago. So FIDO's been around for 10, 12 years. Why is it just finally now becoming a thing, right? Why are we finally hearing about passkeys and all this kind of stuff in the news? Well, main reason for that is that up until recently, we haven't had biometrics on our devices, and we haven't had these security chips on our devices. The security chips are actually what we store, what actually generates the public-private key pair that we saw earlier. So these things have made it possible to actually realize the vision of FIDO on the actual client devices that wasn't there before. So what is FIDO 2? FIDO 2 was after a few years of this technology, this idea, the FIDO Alliance realized, hey, if we want to get adoption with FIDO, we have to make this easier for developers and easier for device manufacturers. So they came up with two standards that really make up the FIDO 2 umbrella. And the first one is called WebAuthn. Maybe you guys have heard of that before. That's a set of APIs that are now pretty much every single modern browser that lets you either register a FIDO 2 credential or authenticate with one. So it's very simple for developers. And then there's something called CTAP2, which is a protocol that abstracts away all the different authenticators that are actually possible with FIDO. I actually got one in my pocket here that I used during the demo. This is a YubiKey, one of those on the screen. So how does FIDO 2 work when you're actually doing a flow with FIDO 2? We'll see this kind of in the demo, but this actually kind of gives you a nice visualization. So let's say let's say it's a single page application, basically JavaScript running in the browser, and I want to sign the user in. Oh, just got locked out. There we go. One sec. Okay, we're back. So I want to authenticate. So the app sends a request to the server, the FIDO server, and says, hey, I need to authenticate. The server is going to send back that challenge. And then what the client's going to do is it's going to use the WebAuthn API to say, okay, authenticate this user. Here's the challenge. WebAuthn kind of takes over and does all the heavy lifting. It invokes the CTAP2 protocol, figures out what authenticators are available to do the actual authentication, presents a UI. When you've seen something like this, it's like a biometric UI or maybe your security key. User does all the good stuff, sends back the sign challenge. The server says, yep, that's correct, and sends back the response, and you're authenticated. So that's real high level in a nutshell how FIDO 2 actually works with an authentication. Okay, so this is my Minnesota side coming out when I say this. What the heck are passkeys? So passkeys is more of a kind of a current buzzword. So about 2 years ago, Apple decided to implement FIDO 2 in their platform. And they had this brilliant idea of calling them passkeys instead of FIDO 2 credentials, because it was a lot easier for everyday users to be able to understand what that means. I think it was a brilliant idea in terms of marketing. So, but they did something interesting. If you register a passkey, let's say on an Apple device, what happens is they actually synchronize that passkey to your iCloud keychain, using whatever Apple ID you're signed in with, right? Not only that, it gets synchronized to all the other Apple devices that you have signed in with that Apple ID. So why did they do this? Well, one of the main reasons they did it was because with passkeys today, account recovery is one of the biggest challenges. If you lose your device, you've lost your passkey. But now they've made it easy. You go out and buy a brand new iPhone, and boom, all your passkeys are going to show up on that iPhone as long as you sign in with the same Apple ID. So that was why they did it. One of the drawbacks, though, is, oh my gosh, now we're sharing passkeys all over on these devices, and my Apple account now becomes the single point of where attackers are going to go after. So make sure your Apple account is very secure, by the way. You can also airdrop your passkeys too, which is kind of nuts. So, all right. So, that's where the sort of the passkey idea came from. Oh yeah, one last thing. FIDO adopted the term passkeys, by the way, in the last year. And so now we actually have 3 kinds of passkeys. This is what a lot of people don't know this. When we think of passkeys today, most people think of the distinct passkeys that are out there, the Apple, the Google, and Microsoft's going to come out with theirs. But there's also what we call a device-bound passkey. This is a passkey that does not sync. It'll stay on a physical security key, for example. And then there's something called an app-level passkey. This is where you can actually have a passkey that actually is contained within an app. Let's say it's a banking app or your favorite pizza app if they want to have passkeys. And this is a stronger credential because it won't sync either. It'll be bound to that application. Okay, we're going to switch gears. Hopefully we have time. I'm going to do a quick demo of passkeys so you can actually see this in action. And so real quick, this is, if you're familiar with the movie, there's a character named Michael Bolton. Somebody actually did a thing where they put the real Michael Bolton in the movie in a skit. But it's a great. This is from like 1999, I think. But we're going to do a demo of Passkeys. What you're going to see is a typical sort of consumer website that's using passwords right now, okay? And they want to slowly introduce passkeys into the mix. What would that look like? We're going to do kind of like a crawl, walk, run migration into passkeys. The demo is actually on GitHub if you want to go download it and try this yourself, because that's where you're going to really be able to see it in action. Go ahead and do that. And you can, there's a bit.ly there if you want to write that down. But anyways, it's going to be using, as far as how the demo is going to work, hopefully if it works, it's going to be using a Google spreadsheet as an actual database, just because it's easier to show that in a demo. So we'll see that change as we go through the demo. And then I'll be running everything locally on my laptop. So it's not going to be out in the cloud somewhere. It's actually running locally because I'm going to actually be making changes as we go. So I'm going to, I need both hands. So we'll see how this goes. I feel like I'm doing stand-up comedy here. Okay. So let me see here. So this is the GitHub site that I was just talking about. It's called the application is called Let's Procrastinate. It's kind of it's a web app where instead of managing all the things you're trying to get done, like a to-do list, it's going to show you all the things that you're not getting done. And it's kind of a play on Let's Encrypt, which is a popular encryption framework. So with Let's Procrastinate, it's basically telling a story of migrating to passkeys. So chapter 0, I'm going to, if you're familiar with GitHub and how Git works, you can have branches. There's a branch called Zero Only Passwords. This is the starting point of Let's Procrastinate. This is the website in its pre-passkey form. And so let's take a look and see what that looks like. I've got it running here, and I can sign in. Let's see here, it's spinning. There it goes. Sign in as Peter. Okay, and nothing too amazing on this site. Again, all it lets me do is keep track of all the things I'm not getting done. So one of the things I have to get done is add passkeys to my new website. Haven't done that yet. So I got that. I started that 6 months ago. Still hasn't happened. So there you go. I've got that. It's doing that great. And if we look at the spreadsheet, this is the actual spreadsheet that's behind the scenes here. Let's see here. This is second. Sorry, Zoom has got its stuff in the way. Hide that. Okay. There it goes. Okay. I was just making sure the spreadsheet was actually updating. So this is the spreadsheet that is behind the website. You'll see I've got these are my different commitments, and here's my users table. So if you've ever built any application that has users signing in, you're going to have some kind of users table typically. So this user table has my username, has my password hash. This is bcrypt. So all this stuff is pretty much just what you normally would expect with a typical website. So and I'll see here. I'll delete this this one as well. So sorry, the internet here, my internet connection appears to be really slow, which is fun. Okay, so now I'm going to create a new account here just so we can have a different account we're using here. So I'm going to sign in as Bill, which is the user we had. Oops, that's my password. Now everybody knows what my password is. Yeah, super secure, right? Okay. So Bill is signed up. Here's his profile. He can change his password if he wants to. So that's kind of our starting point. So now what I'm going to do is back in my GitHub project here. If I go to chapter 1, I'm going to switch to that branch. This is called offering passkeys. This is kind of like, okay, if we're going to start introducing passkeys into a typical web experience, let's do it when the user signs in with their password, right? It's a good time to suggest, hey, would you like to get rid of your password? So I need to switch to that branch in my local repository here, offering passkeys. I have to install some dependencies real quick that are in that branch. And let's see, I also have to apply some schema changes. So what I just did there, just so you guys know what happened there, is that little script created a new table in my spreadsheet database called credentials. And this is important because when we start creating passkeys, a user can have actually more than one passkey per with their account, right? Typically, if you have a password, you just have one password. It's a one-to-one relationship. But with this, we can actually have one-to-many. We'll show that as we walk through this. Okay, so now when I log in as our user, and it's there we go. I have a feeling what's happening is I'm getting API rate limited by the Google Spreadsheet API. So we'll just roll with it. All right, so Bill's going to sign back in with his password. Instead of just going to the website, it's going, hey, would you like to start using less passwords? So Bill says, yeah, let's do it. Here's where I finally get presented with the WebAuthn UI that you were talking about before. This is a little bit different depending on which browser you're in. In this case, I'm using Brave or Chrome is going to look very similar. So I'm going to create a passkey in the iCloud keychain. And I click that button, I'm going to do the biometrics, and it should create my passkey. I'm signed in. And if I hit continue now, I'm logged in with my passkey. And if I go back to my spreadsheet, you can see that the credentials table has a row in it, and it's that same user, and it's got some information. We won't go into all the details there, but you can see that now we have a passkey for Bill. Let's see here. The other thing you can see here with Bill is, yeah, you still got a password. That's all good. Yeah. In my demo, it's just the same user ID. It's a randomly generated user ID that it was created when it's not the user's actual email, but it's basically a foreign key into the user table. Yep. So I'm storing things like public key and a few other things. AA-GUID is actually an ID that represents the type of authenticator that was used. In this case, the biometrics through Chrome. So okay, so let's continue on here. The next chat. So that's pretty basic stuff. And now that Bill has created his passkey, if he logs in again, this is what I wanted to show you next, is I can actually type his username. And now instead of having to type a password, it knows I have a passkey, so it's going to prompt me to use my passkey instead. And so now I'm signed in, which is nice. But even nicer than that, this is kind of whoops, I hit the wrong. There we go. Instead of having to type my actual username, I can just click inside the username field. Notice it already knows there's a user called Bill because I registered this passkey in this browser. So it's going to suggest it. So I don't even have to type a username. So what you're getting is kind of like a password manager-like experience, just natively with passkeys. Okay, let's do real quick. I know we're running really short on time. Let me go through the last couple chapters. So that was just like offering passkeys. Chapter 2 in the story of moving to passkeys here is called passkey only enrollment. And all that means is now if I sign up, oops, I have to check out that branch. Go. So now if I go and sign up here, notice I don't have a password anymore. I can just create a passkey on sign up. So I'm going to create a user called Milton. Tech. Everybody loves Milton. So Milton's just going to sign up with a passkey. He's not going to even use a password. There we go. He signed up. And if we look at the database behind the scenes here, we'll see that there's another FIDO2 credential. And we see that Milton has a user row, but no password. So Milton, the only way he's going to be able to now sign back in is with a password or with a passkey. A lot of websites, most websites that are using passkeys haven't actually done this yet because having no password at all is a little bit of a scary move. But we're fastly approaching that world. So last thing I'm going to show you, and then we'll wrap, is chapter 3, which is being able to register multiple passkeys and manage those passkeys. Because that's important, right? I create a passkey, I got to be able to do something with it if I want to add a new one or whatever. So I'm going to sign out. Let's sign back in. Oh, now we're waiting again. Hang on a second. There it goes. So let's log in. This time we'll log in as Milton. We'll just do the, that's called conditional UI, or otherwise known as autocomplete or passkey autocomplete. It's a really nice feature that's available. So now if I go to Milton's profile page, whoops, I think I forgot to go to the third chapter. 1 second. Getting ahead of myself. Here we go. Sign out, sign in. Milton, there you are. Okay. So now if Milton goes to his profile page, you can see that it shows the one passkey that he's already created. Let's add a new one. So this time I'll add one through the Brave browser instead of the Apple keychain. So there's my Brave, or it just calls it a Chromium browser. And then I'm going to insert my YubiKey as another passkey. Go. I'll touch that one. No, this means you can actually scan a QR code and use your phone to register a passkey. But I'm just going to touch the little YubiKey light there, type in my PIN that I had registered already, touch it one more time, and say allow. Now I'm able to sign in with my YubiKey. And because I'm able to manage this, well, let's show that the credentials, we're getting a bunch more credentials now. They're all associated with that same user, which is the Milton user. And I can go and let's say I don't want a synced passkey anymore. I'm going to remove that one. I can get rid of it. So now the only two passkeys I can use to sign in are that one. So I'll actually sign back in with my YubiKey. Oops, type the right in. Go. And now we're signed back in. So there you go. Sorry for it went really fast, but that's the demo as far as how you can go through and potentially add passkeys to an existing app, web app or mobile app or whatever app you have. Any last questions? I know I kind of went a little over.
We do questions after.
Yeah, sounds good. All right, awesome. Thank you.
What's going on, y'all? I'm Danny Thompson. I'm one of the organizers here as well. So bringing up to the stage next is one of our next speakers, Anusha Kondam. She is the Vice President and Lead Software Engineer at JPMorgan Chase.
Hello, everyone. My name is Anusha. I'm a lead software engineer working at JPMorgan Chase. So my area of expertise is in API gateways. I have worked on multiple API gateway products. And currently I'm working on one of the cloud providers API gateway at JPMorgan Chase. Today, I'm going to talk about strengthening cybersecurity through securing API integrations. So the topics that we are going to cover today is understanding API security, best practices in API security, JWT token and OASP top 10, and then the future of API security. So I'm going to cover pretty basic topics today for the audience. Coming to the first topic, what is an API? API is like application program interface, and any endpoint one can call to activate application code. It can be from machine to machine, or it can also be service to service, and it can be from a curl call or Postman. It can be manually executed through the browser as well. So why is it important to secure your API? If you look at Gartner's report from last year, 90% of web applications are having a wide attack surface. And there are also, the adoption in usage of APIs has increased to 200% over last 12 months. It is very important to make sure that all the security patterns are implemented on your entry point into the application code. It is important to secure the your gateways or like your APIs from any kind of financial losses, reputational damage to an organization, or any legal implications. So what are the risks of inadequate API security? Are data breaches, intellectual property loss, and service disruption. So there are a lot of other damages as well, but these are few of the major herd activities that happen. And there are a lot of organizations which have recently gone through these attacks. And a couple of years ago, T-Mobile was on news for like API security breach. And coming to the best practices when it comes to API security is data encryption, monitoring and tracking, and access management. When it comes to data encryption, a lot of organizations these days have advanced in their API security patterns, but also there are a couple of old and legacy applications still using SSL 1.0 or like SSL 1.2 instead of using the latest algorithms or like latest over to like MTLS or TLS 1.3. And also monitoring and tracking is also very important, because if you look at applications or tools like Splunk or OpenSearch, you can also schedule alerts to know like if your API is really used. There are a couple of APIs which can be like quarterly used APIs or yearly APIs. But if there are any zombie or shadowed APIs, they are really a big problem, because you will not know what is the actual purpose of the API, and they may end up causing a lot of data breaches. So if you notice that an API is not being used for a particular period of time, by scheduling some alerts, like if there is no transaction over last 6 months, you can reach out to the provider of that particular API, which is within the organization, and then ask if the API is really required. And if it is really required, it is a best practice to maintain a documentation of all the APIs. And as a standard practice, it is also a good activity to maintain a taxonomy of the APIs. Like APIs cannot be published in any particular format other than like the organizational standards. For say, if you're picking an organization like Fannie Mae, which has major business units as single family, multifamily, and capital markets. So you should be publishing your APIs categorically into a particular category. If it is not published in a category, then it is very hard when the application grows, and then it is very hard to capture the actual use of API. Coming to access management, authentication and authorization should be implemented on the APIs. And if there is weak authorization that is in place, then there is scope of like breaches. Coming to the central OAuth servers. So a lot of organizations today are like using central OAuth servers. I'll give you an example of like Ping or Okta are few of the products which are commonly used among the organizations which are used for this purpose. All the applications which are hosted internally or like applications which are also having consumers externally are integrated to these applications. For say, if you have an API or an API which is hosted on a gateway, the gateways are again integrating to these OAuth providers, so that they are the center for all the token management, user authorization, and also like central access control. So the token revocation or like any kind of like issues with the token is all handled by the token management server. So a role of API gateways in the API security world is like it would act like a protective barrier. It is an entry point, and it is easy to standardize. Like you can have your common flows which you would like to enforce on your APIs, like any sort of authentication or authorization patterns can all be like implemented as common flows. And this can be implemented on all the APIs. Like there may be different categories of APIs you may be exposing, like internal APIs, external APIs, or like protected APIs. For say, internal APIs are like internally hosted, which an application, the client calling system and the backend as well are internally hosted, whereas like externally hosted APIs are usually having the clients outside of the network and the backend is internal to your organization. So there are different patterns that you use to like accommodate the security needs for these kind of APIs. You can categorize all these APIs and have the standard security patterns implemented, so that they can be like commonly adopted by all the APIs which fall under the internal versus external category. Also, it lets the developers focus on the actual business, because most of the security patterns which are implemented categorically are like repeated logic, and the application developers don't have to focus on building this. A centralized team can build this as a common policy, and then the business logic can be a focus for the developers to like work on. Also, it is a great place to implement your rate limiting, and you also to protect from any sort of denial of service attacks or distributed denial of service attacks. You can also implement your IP whitelisting or like any sort of API key validation for your authentication purposes. Also, penetration testing is one of the important factors to secure your APIs. Accessing security, it helps in accessing security risks, attack. You should also perform attack stimulation and also risk mitigation to achieve this. Always call the experts to do the penetration testing so that the application code is not under attacks. Second thing is using of tokens. It is very important to use tokens, especially using of opaque tokens is preferable, because the short key tokens are usually not base64 encoded. If you take the JWT token, right? The JWT token is usually a base64 encoded token. It can be decoded easily, and then all the content inside the token can be viewed. Whereas opaque token is a short token, which can be sent to the authorization server as an exchange to the short token. You can retrieve a JWT token. And this JWT token can again be like verified using a JWKS endpoint, which hosts the public certificates. And also like you have all the roles, and the roles can be used to validate if a particular user has read-write accesses. It is also called as claims. You can validate the issuer in the JWT token and also the expiry of the token. So these are few of the important concepts when it comes to the token. Again, opaque tokens are better. And if it is an internal API pattern, right, where your client and backend is internally hosted, then you can just, as an authorization header, pass the JWT token and consider it for authentication and authorization purposes. But if it is an external user, preferably opaque tokens are a best approach. And coming to the OAuth 2.0, so there are different kinds of grant types. I'm not covering everything, but the four major ones: the client credentials, password, authentication code, and implicit grant types. So for the client credentials, if you have highly trusted applications, this is for those use cases, client credentials is a good bet. And then for like trusted apps written by internal or trusted third-party developers, then password grant type is the way to go. And you can, in password grant type, client ID and client secret are shared along with user ID and password. As an exchange, an opaque token is generated. And also there is a concept called as refresh tokens, which can be passed to generate the new token instead of passing the username and password and client ID and secret. But this is typically used for like trusted parties. And authorization code is for like untrusted applications by third-party developers. And implicit grant type is majorly comes when you have an application and which is used by a lot of users. You don't know who the user, and they'll be using it from their mobile devices. So implicit grant type would come into play in that particular situation. Again, authorization code, it is commonly seen among we don't recognize the grant type, but usually, right, like for example, if you're trying to use Shutterfly and then print some photos, but you do not want to log in or sign up to that particular website, you may use Facebook or Google to log in and then print out your photos. So here the Facebook or Google are acting as like authorization providers. So coming to OS top 10. So this is your friend when it comes to like validating if you are not sure of like what are the major things that you need to take care while publishing or exposing your APIs to the outside world, for putting yourself out there, right? Like what are the things that you should be considering? OASP is your friend, and then they have like a regular way to like they enhance their security flows as well. Also, when you are trying to decide on an API gateway, like when you are trying to evaluate a product, right? These are the things that you should be considering while evaluating the products available out there. So few of the security risks are injection, commonly the SQL injection, where a SQL command or query is executed by an application. Broken authentication is one of the things where logins are implemented insecurely, and like weak passwords are used, like where basic auth is allowed. It's always an anti-pattern to use basic auth. And also sensitive data is exposed, like passwords or credit cards are used. Always encryption is the way to go. There are different encryption algorithms that you can use to achieve this based on the security standards of the organization. The different encryption algorithms are chosen to encrypt the data at rest. And also the payload encryption is one of the common patterns that is seen. XML external entities, and this is also used. This is used for using malicious XML inputs, accessing the servers. And broken access control is like unauthorized users being able to access the data and functionality they shouldn't be accessing. So security misconfiguration is setting up your systems not in a secure way, like not having proper authentication and authorization mechanism in place. Like cross-site scripting is another one, like whereas malicious scripts are like fed into the web pages, and which are common attacks. And also like insecure decentralization is also one of the security risk, along with components of like known variables, where people use still updated libraries and encryption standards. This is one of the commonly observed pattern, along with insufficient logging and monitoring. So logging and monitoring not only helps you to like understand the errors, but also to like for monetization purposes, as also it is very useful when it comes to the API world, to understand if a particular client is calling your API over a period of time for more than a given time he's trying to hit his limits, then it is a negotiation point to talk to the client if we should be increasing the limit for them. So there are a lot of monetization APIs available out there. And coming to the emerging technologies, when it comes to the API worlds, like dynamic defensing is through the AI and ML world is one of the topics that is getting a lot of traction. And conversational APIs are like the ChatGPT APIs, which store the context and then provide you like a particular way to answer your questions. I mean, if you're trying to store the context as an IT professional, the answers would be in a certain fashion. And then also like automation and standard enforcement is also like getting a lot of traction, along with API ops, like SecOps and like DevOps. API ops is one of the other topics where all the lifecycle management of API is done in an automated fashion. Yeah, that's it. Thank you.
All right, y'all. Our next speaker is Serena Dipenti, a security analyst at Black Hills Information Security.
All right. Hi, everyone. Thanks for all coming out, and thank you, Danny, for inviting me. My talk is going to be about open source and offensive security. To the next slide. Okay. Here's a little bit about me. My name is Serena Dipenti. I was like the only one that didn't have a fancy title on like the 5 speakers tonight. So I put Director of Security Analyst. And I don't, you know, who's going to know the difference? Okay. So my work experience, I started at Cisco as a, I guess their TAC team. I was an engineer there, a network engineer working on unified compute. And now I'm a security analyst at Black Hills Information Security doing offensive network security. So I'm a pen tester, and yeah, I'm originally from Ohio, went to Akron University, and now I go to SMU. You might know me or have seen me on Twitter as She Networks. That's what I go by most of the time online. But, you know, most notably, I feel like I'm known for the reason Elon Musk is removing blocks on Twitter, which is a whole other story, but we're not here for that. Okay. So I wanted to talk a little bit about offensive security. I'm not much of a developer myself at all. I do some coding as a part of my job to make my life easier. But then I also rely on a lot of community support. So in offensive security, I would say a little definition here says protecting systems and networks by actively engaging in threats rather than passively defending. And the primary goal is to think like an attacker, expose vulnerabilities, and mitigate possible breaches before they happen. So like pen tester or red teamer is just like the corporate word for hacker. Moving on. Okay, so there are a couple different options. When you look at the offensive side of cybersecurity, you will hear red teaming and blue teaming and pen testing and assumed compromises and pivots. And there's a lot of terminology here. I want to cover some of the top ones. Pen testing, what does this mean? It basically is you are trying to find as many vulnerabilities in a system as you can in a relatively short period of time. So if I do an external engagement, which is testing all of their systems that are externally facing towards the internet, maybe depending on how many endpoints they have, it would take like 3 to 5 days. Internal networks, what we would call an internal assessment, is where they drop us into their network and we basically just see what we can do with that information and how we can escalate and elevate our privileges. And we put in a report. This is very noisy pen testing. It's not meant to be a surprise when, you know, attackers are actually attacking your application or your network. They typically want to be quiet and not tip off anybody that might stop them or, you know, ruin what they're trying to do. So this is kind of where red teaming comes in. Red teaming is more of an attack simulation where you are not trying to tip off anyone. You are trying to be covert and be quiet, and you usually have some kind of objective or goal. If it's, you know, specific information that they want you to see, if you can access, or, you know, just there's some kind of goal that they kind of want you to do, and they're typically longer engagements. Now, there's also exploit development. I put this on here. Has anyone ever heard of the NSO group or Pegasus spyware? Okay, cool. Yeah, so if you haven't heard of the NSO group, they're basically a company based out of Israel, and they make and develop iPhone or mobile phone exploits. It's kind of like their typical bread and butter. And then they sell that technology to governments who then use that technology for spying purposes. And, you know, you can get hired at the NSO group. I don't think any of you can, though, because it's kind of like banned here in the US now. But you could get hired at the NSO group, and your job would be to find exploits on phones that they can use and incorporate into their Pegasus spyware, because obviously, eventually, some of those exploits get found out and get burned. So they have to continuously churn out new exploits to keep their product running. So yeah, that's kind of an interesting one. Now, I wanted to break down a little bit about what kind of threats or hackers that you're typically facing in your application or environment. I would say the first is probably the most common people know about is ransomware groups. These groups have changed a lot over the years, but mainly we're going to see a group of people that they kind of run like an organization now. Some of them focus like purely on writing the malware. There's other people who will gain initial access through, you know, social engineering or phishing, sometimes credential stuffing, as we had heard in the first talk. The next, you know, these people are financially motivated. They want money. Now, the next one I have over is state actors. Typically, these are government supported actors. They are sophisticated, often working with 0 days. They're not typically going to be, you know, calling you or writing you a phishing email. They're a lot more sophisticated because they have resources. And most of the time they're looking for intelligence. However, we have seen cyber attacks that were, you know, in Ukraine specifically, Russia and Ukraine, I'm sure a lot of people are familiar with the conflict there. But before war even happened, there was a lot of cyber attacks from Russia to Ukraine, and probably vice versa. I don't know all of that, but Sometimes they want to sabotage, electrical grids or backup systems. And that can be really detrimental, obviously, to the population there. And, hopefully we don't see an increase of that, but that is a possibility. There are also hacktivists. They're politically motivated. They're more interested in intelligence, denial of service, reputational damage, and then just kind of like the opportunists who are like, oh, I found this exploit, I'm going to take advantage of it. Like maybe you figured a way to like give yourself gift cards or something, and then you just keep doing that forever. Now, the difference between offensive security and a hacker is that hackers, black hat hackers, or I don't know, unethical hackers, they have all of the time in the world. As a pen tester or a red teamer, you are limited to a specific scope of time, whether it be days, weeks, or months. And that can really limit what you are able to do. And we're also limited by scope. So sometimes a company will come to you and say, hey, I want you to check out, X, Y, and Z, but they might scope out like, you can't touch the API or something like that, right? And so obviously hackers that are hacking for nefarious reasons are not limited to a scope. They're gonna attack whatever they can possibly get their hands on. And yeah, so in offensive security, you do have some disadvantages. One way that we kind of compensate for these disadvantages is we use a lot of open source tools. Has anyone here contributed to an open source project for an offensive security tool? Which one?
Oh,
cool. All right, awesome. Yeah. So my job runs off of these open source tools, just tons of them, hundreds of them. Without those, it would be impossible to do our job, right? In a 3-day time span or a week time span. You need so much more time. The advantages of open source is it's very accessible. There's a lot of community involvement and support. The code is easy to review and modify. We had, one exploit recently with like the Kali, or not Kali, it was just like a Linux thing. And, somebody was able to audit the code and see that someone had put a backdoor in. And that is one of those benefits of being able to see that, especially when we are using these tools in customer environments where we don't want to put actual malware on their systems. We would like to put our malware that we have more control over sometimes. So yeah, and it's easy to review, quick development, all that good stuff. Now, who's heard of Mimikatz? Okay. All right, so Mimikatz was developed or released in 2011. It was a Windows exploit that basically was able to take clear text credentials out of the memory of a Windows computer. Now, Benjamin Delpy, who discovered this vulnerability, submitted it and disclosed it to Microsoft. And then Microsoft said, well, that's not a problem because you already have to have that computer compromised. So, right, that malware would already have to be on that computer to access what is in clear text in memory. So in May 2011, Delpy released Mimikatz, and it was kind of, I would say we're still dealing with the effects of it. And I don't blame Delpy. I think he did what is right. This happens a lot of times. A lot of times in the cybersecurity industry, you will go ahead and disclose something to the company and they just say, oh, that's not an issue. We're not worried about that. And then it ends up being a really big issue because once they've disclosed it and said it's not an issue, well, then what's stopping me from writing code to exploit that non-issue? So that's basically what happened. Delpy wanted to learn C and more about Windows. This was like his first C program. Which is kind of like wild to me. And so he released Mimikatz to the world and said, hey, look at this proof of concept. I am able to get clear text credentials out of memory in a Windows computer. He was invited to talk at a conference in Moscow in 2012, where he was like Men in Black. He was downstairs, complaining to the front desk at the hotel that the Wi-Fi wasn't working, he couldn't connect. And then the person at the front desk was like, oh, okay, we'll just hang out here for a minute and we'll go, you know, look at that. And he said, no, I'm not going to do that. I'm going to go back into my hotel room. And when he went back up into his hotel room, there's a man in his hotel room with his laptop. So yeah, they wanted to basically steal Mimikatz, or, you know, more of the research and information, because threat actors realized how powerful this exploit could be. And it was, because now present, we've seen Mimikatz used in a variety of different ransomware. And you know, how it spreads typically is you do infect one computer, and then from that one computer, you get to grab credentials out of those and start logging into other computers and dropping the malware in. And so this has been a huge non-issue from Microsoft. And that's not the first time that they do that a lot, actually. So this is an open source tool that you can also incorporate. It is available on GitHub. But I wanted to talk about a couple of the other tools that I use. This is kind of high level overview of a few of them. I wish I could cover more of them. One that I use pretty frequently is Eyewitness. You know, if I am in an internal pen test and they give me 1,000 endpoints and I have 2 weeks to test, I cannot physically look at every single endpoint in 2 weeks, right? I would spend most of my time doing that. So what Eyewitness does is you give them a range of IP addresses and it'll take a screenshot of whatever web page is going to come up. And then from there, you can kind of determine like what looks interesting to you and what doesn't look interesting to you. Next is Credmaster. I use it a lot for credential stuffing and brute force attacks. We have a database at work that has all of the data breach dumps that you could possibly imagine. And I will, when I'm working with a customer, I'll specifically kind of look through data dumps to find any email addresses that their employees had, any passwords that they use that we have in this database. And then I can use Credmaster to basically just spray email addresses and passwords at endpoints like, you know, a Microsoft 365 login. And Credmaster also has the ability to interact with the pass-through API. It says pass-through. Anyway, you know, I should have read that. Anyway, so yeah, use AWS as a pass-through proxy and rotate IP addresses for every authentication attempt. This is great because obviously a lot of applications have web application firewalls, and you're gonna get burned. They're like, hey, why is this one IP address sending all of these attempts? So by using AWS, you can rotate out your IP address through every attempt, and this helps you kind of bypass those web application firewalls. Sure.
Like, I don't know, let's say I put the term. You have a program that rotates the IP for how that.
You would do this with Credmaster. Credmaster has it plugged in, so you're going to use an API key, basically. You'll get an API key from your own Amazon account and then just use it with this tool, and the tool prompts you for like your API key. And then also like a list of email addresses and passwords, because sometimes you don't like want to do credential stuffing per se, because maybe there's not a lot of data. You just want to try and say, hey, I want to try like winter 2024 exclamation point. And you'll just do this thousands of times for as many accounts that you can find. And it's fairly successful. So the next one, this one is a newer tool called Graph Runner. I'm not sure if anyone here is super familiar with the Microsoft Graph API. This was a newer API to me. This basically helps you exploit some of the, I would say, weaknesses for Graph Runner. With Microsoft specifically, a lot of their settings by default are very permissive. So you can, as a, you know, an account holder of a 365 account from your work, right? Whatever domain you have, you might be able to add applications, and those applications are going to have their own kind of login information. So if you were able to exploit an employee's account, let's say my winter 2024 password attempt worked on one of the accounts and I can log into that, I can go ahead and spin up a new application that will have its own set of credentials. And in case IT catches on to me that I am accessing an account that I'm not supposed to have access to, they will disable that account access, change the password, but because I've deployed another application, I've maintained persistence in the environment. I haven't actually been kicked out. And that's a default setting for most people, right, that have this account. So you really have to kind of go through and do this. You can pillage data. There are a lot of settings. Microsoft has one where if you change it, you can view other people's inboxes, like their email inboxes, which is great because then you can reset passwords using the other people's emails that you don't even have the password to. And yeah, this is a post-exploitation tool set, and it's great. There's also another one I put on here is Evil and Nginx. And this is a good man-in-the-middle tool framework if you are trying to phish someone or send them to a bad website to help you either, get their credentials or, bypass multi-factor authentication. You can basically make a website that's literally the same. And yeah, but these are only a few tools out of, like, I'm not kidding, thousands of these open source offensive security tools that are available. You can use these as offensive or defensive, right? Because oh gosh, I have SQL map, but you can use these offensively or defensively. There is one tool like Bloodhound. This is a really good one for Active Directory vulnerabilities. There's like, I don't know, a billion Active Directory vulnerabilities, and it would be way too hard to kind of find every single one of those on every test. So we have tools like this, and they can map out Active Directory and basically say like, hey, you can go from the account that you currently have and pivot into a domain admin account if you apply this certain certification or exploit this one vulnerability. And this kind of helps out, and this saves a lot of time, right? Because again, limited time, limited scope. And we want to, you want to get the most out of your pen test. And if you're a defender, maybe you should be running these tools before you do your pen test so that you can kind of fix some of these issues or be aware of it. Because I think, especially when it comes to like Active Directory, a lot of people aren't super familiar with it. It's not a very exciting or fun thing to learn, in my opinion. And again, with how many different options Active Directory has, that kind of introduces new exploitable paths. So, yeah. Any questions? Yes. Yes, yeah. No, that's my company makes like a D&D game card thing for backdoors and breaches to help with incident response. So yeah. But yeah, if you have any questions, feel free to ask me afterwards and come say hi.
All right, I'll bring up the next speaker. Some of y'all may know him. Clint Myers, senior front-end developer at Dialexa, an IBM company.
All right, hello again, Clint Myers. I was up here earlier. I'm going to talk a little bit more in depth about JWTs, and then I'm going to talk about a specific problem that I encountered and potentially could utilize JWTs in part of the solution to that problem. So yeah, this is me. I work for Dialexa, an IBM company. Usually do UI work, but I'm interested in security. So whenever I can at work or in my personal stuff, I try to kind of dig into security stuff just to boost my knowledge there. I switched to dev in 2018, coming from metallurgical engineering. So been pretty active in the last 5 years or so, doing a lot of Angular and React professionally. So the big caveat in this whole thing is the takeaway, stand on the shoulders of giants. Like, don't try to reinvent the wheel. Like I'm talking about a specific problem where there's kind of a gap, where there is kind of things missing that you could potentially, be a little inventive and use some ingenuity. But in general, there's a lot of solved problems out there. So lean on the really good frameworks, the robust security libraries, best practices and things like that. Try to do things the way, you kind of figure them out to be best practices and whatnot. And when you need to get a little inventive, at that point, you can go outside the box a little or something like that. Okay. So I'm going to dig in a little more about what a JWT is than you might have heard earlier in the night. So a JSON Web Token, it's self-contained, it's structured, and it's verifiable. And I'm going to go into kind of the details in future slides about what that means. And it's used in both authorization and authentication. There's different types of tokens, such as ID tokens that show information about who you are, and an access token that has information related to what you are able to access. If you have a door and you have a key, you can open that door no matter who you are, right? That's kind of what an access token is. If you see this little link here, if you have your computer open, you can try to go to that link. I wrote like a tiny little token generator, and we can look at, basically look inside of tokens and verify them in real time on a website called jwt.io, which I'm sure plenty of you guys have been to look into tokens and see what's in there. JWTs, anything that's stored inside of a JWT it's out there, right? You can look in there, you can read that payload. You don't need anything special to do that. It's always got 3 sections, and those sections are essentially strings that are separated by periods. You have a head, you have a body, and you have a signature. Inside the head, you're going to store the algorithm that's used in regards to the signature. I'm going to talk a little bit about that in a future slide. Inside of the body, you have registered claims, public claims, and private claims. There's a handful of registered claims that are kind of like the most used things about the JWT itself. One of the most important things is, when does the token expire? That's something that, whether you're doing it or a library is doing it, you always want to verify that the token is still valid, because generally those tokens are going to have short lives. And like somebody said earlier, probably paired with potentially a refresh token, so that you can get those tokens, get new access tokens with a refresh token. One of the little kind of security things you can add in there is like utilizing HTTP only secure cookies with, if you're keeping a refresh token and let's say you need access to your access token, maybe there's something in there where you would store that slightly differently to have access to it in, say, your JavaScript or something. Keeping your refresh token in HTTP only secure cookies is kind of a little thing to keep it safer. Other information like the public and private claims are kind of other information. You could store things like email, and the less you store in your JWT, the better. But if you need to store additional information, you can store additional information in the body. And then the signature is kind of a combination of the hashing algorithm, and then the head and the body. And it's utilized essentially if you put that right stuff, if you have a key or a secret that you can utilize with a hashing algorithm, you essentially verify the signature. In terms of algorithms, there's some algorithms are symmetrical and some are asymmetrical. So symmetrical means that if you have a secret, that secret can be used to create new tokens as well as verify existing tokens. There are also asymmetrical algorithms which have both a private key and a public key, where the private key can mint new tokens. The public key can be used to verify signatures. In general, like most web apps, like you're probably going to be dealing with JWTs that have asymmetrical hashing algorithms, just because it makes sense from a security standpoint that you want to keep the ability to create new tokens as secure as possible. But you want maybe potentially other people to be able to verify tokens. So if you are the person who's creating the authorization server, you want to keep that close to your chest. so that people can't just create whatever kind of access they want, right? And then next to the hashing algorithm, the number 256, 384, 512, basically more bits, I guess, more secure. You're producing, it's the number of bits that are, I guess, produced in the signature is what that that number means, I believe. Yeah, so I want to talk a little bit about OAuth 2.0. So what you're seeing here next to each other is two separate flows. One of them is the authorization code flow on the right, which is used with more like traditional server applications. So if you have something like either an SPA and an independent backend, or if you're using something like Next or Remix, something that has a server, that flow on the right is the traditional authorization code flow. And on the left is an example of authorization code flow with Pixie, where if you're using, we had the advent of SPAs in the last 10 years or so. We had a big kind of uptick in, Angular and React and things like that getting popular. Pixie is a slightly newer flow that essentially allows native apps and single page applications to be safer than something like the implicit flow, which is potentially being deprecated. So it just improves security for those types of applications that potentially don't have access to a server where they can do the traditional authorization code flow. So you can use that flow if you have that type of use case. When you use OAuth 2.0, a lot of times, there's social logins, you could, whatever providers, GitHub, Google, and whatnot, a lot of them will provide you with JWTs back, but not all of them do provide JWTs. One example is Google, which does provide an opaque token. You may not know that unless you try to take that Google OAuth token to like jwt.io and try to read inside of it, but you're not going to be able to. There's pros and cons to that. Obviously a big pro for Google is just kind of, I think, opaque tokens are just kind of more secure, I think, potentially. But the thing about it is the big difference is that you have the option with JWTs of verifying those yourself, right? We talked about the public keys and private keys. If you, own your own resource server and you're doing your own JWT verification, there may be a use case where you're doing a lot of verifications and potentially that's a lot of API calls. And maybe it makes sense that, you're saving, if you're doing so many API calls to Okta or Auth0 or whoever, potentially that's a cost savings. But you do have the option with JWTs, and you would be required with opaque tokens. If you want to verify those tokens, you would be making those additional requests to the authorization server. So while opaque tokens might look like JWTs, if you don't know the difference and you just see like a bunch of strings or whatever, they're not the same thing because it's a proprietary standard connected to that provider, as opposed to JWTs, which are conform to an open standard. Yeah, I guess I'll take like a minute. I'll just like super quick what my problem was and the solution that I essentially went with. Imagine you do the Pixie flow like I talked about earlier, and you have an SPA and you have some sort of server. So it's a full stack app, but you're not using something like a Next or a Remix, and you want to do some integrations. And there's a bunch of sensitive data in that third-party integration. What you're going to want to do is, I talked about those claims earlier, stuff about the token expiration, who issued the token and whatnot. Assuming on the left there, you do your whole flow without involving the server at all, and you get a JWT into your SPA. When you take that token to the next step, right? When you're making those requests, and let's say you want user by user data, but you only have access to something like a super admin token that could potentially get access to everything in Salesforce for everybody in your company. You have the option on that server when you're making those requests to verify each of those claims in a middleware. And that's a potential solution to a problem like that, where you would look at expiration. You would make sure that the person issuing the token is the right URL. That there's even like a claim for if, say, you made a game and you wanted people to pre-order it, you could send out tokens to that game where the token isn't even active yet, and you could verify that and say if they're trying to access my game early, like something like that. So there's a lot of claims that you can essentially validate yourself. But like I said, stand on the shoulders of giants. Use when you can best practices and existing solutions, because almost everything has been figured out, and there's a lot of people out there that are a lot smarter than you. All right, thank you. So we have one more speaker tonight. Yeah. Okay. Yeah, we have one more speaker tonight. He's actually a friend of mine.
All right. Yeah, thank you. So everyone hopefully can see my slides. I forgot to ask. I think I can see in the background there. Yep. All right. We're gonna go with good. So yeah, thank you everybody. I'm the last presenter, bringing in the rear, the way I tend to go best. No, I'm joking. So yeah, my name is Gabe Marchall. I'm a principal security consultant. I work for a consulting firm, which I'm not. This talk isn't officially through them, so I'm redacting that from my slides. But if you just want to look at my LinkedIn, you could easily find out who I work for. But that's not what I'm here for. Anyways, my talk is called "You Need a Pen Test," or actually, "Do You Need a Pen Test?" So I'm going to be talking about some of the examples of when you might need a pen test, when you might actually not need a pen test, and go over what a pen test is. I know we've heard a few other presenters talking about that already, but I'll briefly talk about it from my perspective at least, and then go over the difference between that and vulnerability assessments, maybe briefly touch over red teaming. So currently I'm one of the lead red teamers at the firm I work for, but my heart is with AppSec. That's how I first got started with security. I started out trying to be a developer. I wasn't a very good developer. Funny story is, one of the things that really got me into security was making CTF challenges, making like intentionally vulnerable web applications for the most part. So I like to say that I'm very good at writing bad code. Yeah. So moving on. So what is a pen test? We're not going to dig into this too much, but it's really, when you look at vulnerability assessment compared to a penetration test, compared to red teaming, it's all about depth versus breadth. Whether you're focused in on a single application, or are you trying to simulate a scenario on what's going to happen if can an attacker get into our network, get to XYZ, and get out without being detected? But for the most part, what we're really talking about here today, even though all the time you'll hear pen test or web pen test, really what that is more, at least when you look at like the NIST definition, it's more of a vulnerability assessment. So, but even with that said, I'm still going to use the word pen test just because everyone's so used to hearing pen test. But typically a pen test is more about actually trying to simulate the exploitation of vulnerabilities that are found versus just trying to find as many vulnerabilities. So when it comes to looking at web applications, which is what I'm mostly talking about here today, you're more along the lines of looking for a vulnerability assessment. But that said, every salesperson out there in the world is going to be like, what are you talking about, vulnerability assessment? Yeah, we sell web pen tests. We can do that. So I mainly just talking about this because sometimes it can be confusing when you hear one person say web app pen test, another one will say vulnerability assessment, but more the same. They're pretty much synonymous. And for the sake of this talk, I'm just going to keep saying pen test, so forgive me. And then red teaming, I'll just briefly mention a second ago, it's more goal-oriented, more the goal of those, or the outcome is usually trying to train defenders and prove whether or not an attacker can accomplish a certain task based on the defined scenario. So, but really what we're here to talk about right now is just mostly web app assessments, web app pen tests, whatever you want to call them. And let's see. So when you talk about we're going to call them assessments, pen tests, whatever, for a web application, there's three main types we usually will hear talking about. Either a black box assessment, which means the tester is going to have little to zero information about the application, no access to source code, no access to logs. It's typically the easiest to set up because you don't have to, at least the application owner doesn't have to do any work on their side except for just getting access to the environment set up. But it's not the most ideal, and I'll touch on that. But for ideal reasons, the more information you give a tester, the better. Gray box testing would be the next level. So that means you were able to give the tester some level of access, whether it's maybe a limited amount of source code. Maybe there's multiple repositories, but you're not able to give them all of them for one reason or another. You might be able to give them access to logs, but maybe not everything. They definitely don't have the ability to hands-on debug the application. Gray boxing is probably what I tend to see as being the most common because it's kind of an easy or a good kind of spot in the middle that's easy for both parties to accomplish. Ideally, if possible, and if you really have if you have your code organized, your dev shop's really well organized, a white box testing is definitely doable and is definitely the way to go. That does include giving the tester full access to source code, and I know that sounds like a nightmare, but it's pretty standard with doing pen testing. NDAs are always in place as part of the statement of work. Even better if you're able to have like a easily reproducible environment, like let's say just a Docker Compose file that can easily set up a local instance of that application. That's even better. I mean, it's rare, or well, I wouldn't say rare, but it's not incredibly common that I come across that. But when clients have that ready to go, it makes the testing way more efficient. You're more likely to find bugs that you wouldn't otherwise, being able to actually debug the application and get a live view of the logs as well. All right. So moving on, but why do you need a pen test? That one's kind of hard to say multiple times, but why not? Yeah. First option, because fill in the blank says you have to. This is probably my least favorite reason. Some clients, customers, whatever you want to call them, it's just for compliance reasons. It's just to check the box. They have to do it because they handle credit card numbers, because they're handling health data for HIPAA compliance, or they have another customer of theirs that says we want you to do a pen test if we're going to buy your service or whatnot. That's definitely a reason. I mean, it's a valid reason to do a pen test. It's not my favorite, and the reason why I say that is obviously you want someone who's requesting a pen test to actually care that a pen test is happening. You would hope that they want their application to be secure as well, which normally they do. It's rare that you get the individuals that just completely could care less, but it does happen occasionally. Why else would you possibly need a pen test? Well, really the main reason is because hackers going to hack. It's like, do you want to find the vulnerabilities before someone else does on the internet? Well, that's a good reason to get a pen test. And trust me, this is not a sales pitchy deck. I'm going to kind of go over some different solutions based on kind of how to maximize your budget as well. And then secondly, also just gaining additional confidence in your overall security posture. So as well as improving the security of your users. I mean, hopefully, I think most, if not everyone out there is a good person, and if you own a company, you have an application, you want your users' data to be safe. You obviously don't want to be compromised. I mean, first off, for your own financial reasons, but then secondly, just for the good of other people as well. And then lastly, kind of a bonus opportunity, pen tests, vulnerability assessments, whatever you want to call them, can kind of offer as a training opportunity for your engineers and developers. And the last little bit there I have on the slide, even if you come away from the test without any findings or maybe just a couple of lows, informationals, still that process of preparing and being ready for a pen test is going to be beneficial. It's going to make sure that you have all your ducks in a line. You have obviously your code's up to date, but your documentation's up to date. You have someone that's fully aware of how to walk through the application for someone else, kind of a knowledge transfer process. So it's definitely a lot of different use cases of why a pen test can be beneficial. All right, so kind of going into some examples of when you might need a pen test. So YNAB, this is going to be probably if you have a very complex application or a legacy code base, Definitely probably need a pen test, especially if you've never had one before. So let's say, for example, your application's multi-tenanted, you might have shared hosting, or even has like complex functionality that includes some sort of data transformation, like serialization, especially if it's like consuming XML, especially if you're using Java or .NET and doing that type of stuff. Things can get pretty dangerous if you're not doing it the right way. In those cases, definitely you probably need a pen test sooner than later, especially if you've never had one before. Also, I don't mention the slides, but if you've had one before, and it's been a few years, and all of a sudden you're rolling out a brand new version that changes a whole lot of functionality, then yeah, it's probably a good time to go ahead and do another pen test so you can get a fresh look at how things have changed. Secondly, kind of jokingly, but somewhat seriously at the same time, if your application is held together with spit and glue, I think some of you probably out there know what I'm talking about. If there's, for some reason, your application in production crashes once a month on the dot, and you don't know why, well, first off, you have other issues going on probably, but you probably also could use a pen test just to make sure that there aren't other dragons that you haven't uncovered before. And then next, if you're handling sensitive data, especially if you're storing it, but please avoid storing sensitive data at all costs, you definitely should look into getting a pen test. And lastly, if your app is developed mostly by third-party staff or staff no longer a company, an example of that, if you have an application written in VB.NET or something like that, you definitely need a pen test. All right. And one more, if you enjoy long walks and rolling your own auth or crypto, you obviously need to get a pen test. Please don't roll your own auth or crypto. Something Clint said in his last talk, relying on like leveraging known frameworks with, I think it was the JWT stuff he was talking about, like someone else has already done it correctly and is probably smarter than you are. So save yourself a lot of headaches and use known secure libraries. Don't find some random project on GitHub with 3 stars, but go, you know what I mean? Find trusted projects and use those when you can, for sure. Oops. Okay. So why? Well, sorry, I have trouble saying why not. Why would you need a pen test, but or why would you not need a pen test, I guess is what this slide should be. If you have a very simple application, and I know you're going to say, what is a simple application? This is all very, I mean, it's debatable, I guess you'd say, but if you're dealing mostly with static content, especially like a Next.js, Gatsby, Vite, whatever those static web pages, you definitely do not need a pen test. I've sadly done pen tests, like a 4-day pen test on a 2-page static website. There was literally nothing. I felt bad. I told the customer even like there's nothing else for us to test, and that it was one of those compliance things that they didn't really care. They wanted to check the box, but still, if that's the case, and you have a very simple application like that, and you have a customer or some compliance thing saying, hey, you need a pen test, make sure you do not buy anything more than like a day's worth of testing, because if it's a static app and it's literally just that, you're not interacting with any type of third-party APIs, there's no need to waste money on a pen test. And then even more so, it doesn't necessarily have to be just a static application, but if your application is still very simple, doesn't have any interaction with databases, especially if there's no user inputs or not many, or that user inputs just thrown into a Google Doc, Airtable, something like that, you might not need a pen test. I mean, it all depends. I'm not going to say you're going to be completely secure as long as you don't have a user input that's going into a database. There's obviously going to be things you can mess up along the way, but you might not need to prioritize it quite as much as others if your application is as simple. These kind of the examples I'm giving. Same thing as if you just have your application is basically just a couple of different serverless functions that, again, don't pass user input to a database, or don't pass user input to some shell command. Hopefully that would not happen, but it definitely does. I think you get what I'm saying. You kind of have to determine on your own. Well, obviously you can get the consultants to help, but just even before you get to that point of having to talk to different consulting firms, just try to think about like how complex is your application, is it worth spending the money on it at the time? Next, startups. I mean, that's probably the most common question I hear from friends or friends of friends who work for startups is like, do we need a pen test? And it really, again, it depends. I mean, the first thing I would ask is the application already publicly accessible? And then furthermore on that, is it the type of application where just any anonymous actor on the internet can sign up for it? Or is it something that's paywalled to where like your enterprise sales people have to set up an account for them, or it's invite only, something like that? If it's something where just anyone on the internet can sign up for and there's a decent amount of functionality, then yeah, it's probably time to get a pen test. Otherwise, you could probably wait a little bit, but obviously at some point you're going to need one. It's just, again, prioritizing where you spend your money. And then lastly, if you're storing lots of customer data and expect a large user base early on and you're not public yet, I would still definitely recommend having a pen test if you think the second you launch, you're going to get a lot of activity, a lot of users signing up and storing their information. And the too long didn't read version of that is just think about your application and think about what is the worst thing that could happen if someone compromised my application. I know that a lot of times people are like, well, I don't really know, but that really requires you to talk to your more senior developers, engineers, discussing kind of threat modeling out what your application, what your application does on a technical level. What are the worst case scenarios of what could happen if things go wrong, and that can kind of help lead you decide whether or not you really should prioritize spending money on a pen test. All right. So maximizing your budget, and when you've decided that, yeah, you probably need a pen test, one of the first things that I would definitely recommend, and this is what my salespeople would hate for me to say, is always, you're always going to want a time box assessment. I mean, for the most part, every assessment is going to be time boxed in one way or another, but you need to go into those initial discussions with the sales representative with what you're expecting, what you're looking for. The worst, I mean, actually, the thing that a salesperson wants to see is like, oh yeah, we've got a budget of $50,000. Just give me whatever you got. Please don't say that. You're going to waste your own money. What you really should do is prioritize, again, the functionality in your application that you're most worried about, and be upfront with the salesperson, whoever you're talking to. Let them know what you're looking for. Say, we want to make sure that testing of, I don't know, let's say password resets, blah, 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 maybe data import of this application is heavily tested. Not sure what our budget is right now, but we were thinking 10 to 15 person days. We just want to know what that's and what kind of range that's going to cost you. That's definitely a much better way to go about it, and that's going to help kind of lead the scoping effort that's done by the consulting firm, and will definitely help you save some money, in my opinion, at least. Shopping around, kind of on that note as well. I know it's not fun to talk to salespeople. I absolutely don't like doing it myself, but shopping around is definitely going to help you save money and will help you learn more about the process itself. So talking to a consulting firm, having them scope out your application it's completely free for you. That's the only way to really make the sale, is for the consulting firm to have to scope out your application, make a proposal, say it's going to take us X amount of days, it's going to cost this amount of money. But definitely using multiple different consultant firms, compare prices. Obviously, it's not just about how much things cost, because some are going to cost more than others. Can't talk on that anymore. But you really, honestly, to me, it would boil down more to the feel you get from the people you talk to, because normally you'll have the salesperson as well as the consultant that hopefully is going to be doing the testing. That actually brings up another good point, something you should ask. If you have a penetration tester on the scoping call, make sure you ask, are you going to be part of the actual testing that's conducted? Because in some cases, that's not going to be the case. And that you might be expecting one person, you're going to be working with one person that you really kind of hit it off with, connected well with, and then it turns out someone else is going to be doing the testing. So, but yeah, I think there's a part of it that really, not alone just the amount of money it costs, but also just kind of the feel you get from talking to the different firms, making sure that you feel like you have a good connection with them, because it really, to make a penetration test as efficient as possible, you need to have good communication both ways between the penetration testing firm and the team responsible for the application. I do mention here, if you really are on a tight budget, it is possible you can hire independent testers. They can definitely save you money, but it comes with its own risks. Definitely don't hire someone off Fiverr. You're just going to get a quick scan and some sloppy report, most likely. I mean, I've never personally done that, but I've heard horror stories by all means. But I would only recommend that to really, if you're going to go to the independent testers, if you're more in the startup line, let's say you maybe haven't gone public yet and you just want to get a good look at your application, especially if you have a referral, someone you know, a friend of a friend of a friend, that type of thing. But for the most part, really the best way to do it is go with a consulting firm, but just go into that conversation not disclosing what your budget is initially. It's kind of like whenever you talk to a recruiter that's trying to hire you, they always want to ask you like, what's your hire, like what's your salary range or how much you get paid currently? Like you're not supposed to answer that, kind of puts you at a disadvantage. So think the same way when you're looking to get a pen test done. And I kind of already covered this, but yeah, focusing on whenever you have those discussions about what you're looking for, if you're on a tight budget, focus on saying, I just want these critical pieces of application tested. I'm not worried about X, Y, and Z. We'll cover that at a later date. And if you're curious, like I don't know what the critical functionality is, anything to do with complex functionality, I mean, ask your senior developers again, your engineers, anything with financial transactions, user management, like password resets, even user sign up. Especially if any of that stuff is homegrown, definitely that would be areas of logic that I would definitely want tested. And then if you're looking through your code and you see like at the bottom here, dev comments like this, like bug or bug fix number or whatever, this is hacky, going to work on this later. If you see lots of that, you probably should make sure that testing gets a good look at that area of the code. And that's something definitely see quite often. So moving on to preparing for a pen test. So let's say you've kind of agreed to a budget, whatever, or even in some cases this could be before you even talk to the consulting firm. How can you kind of prepare for a pen test overall? Maybe this might even help you maximize your budget as well. But if you have the technical skill in-house, and this doesn't have to be someone that's a pen tester, but a developer who knows what they're doing, they're a full stack developer, they could probably figure out how to use, there's open source tools that, excuse me, I know a lot were mentioned in one of the previous talks, but from the web app side, the Z attack proxy, which is, I can't remember who actually made it, but it's
Hey,
OWASP.
Gabe,
Yep.
sorry to interrupt. We have about 1 minute.
Sure. Okay. Almost done. The Zap tools, funded by OWASP, definitely great. SimGrep is great for static analysis. And if you can do those scans on your own, it can definitely help influence testing, maybe even save you a bit of time and money. But the caveat on that is automated tools, they will help you find low-hanging fruit, but that's about it. I wouldn't rely on it to get anything more than that. I'm going to go through this really quickly, but again, leverage your senior developers when preparing for a pen test. They're going to know your application better than you will. Definitely get them involved in the scoping process as well as the pen test itself. Giving them some level of ownership in the pen test process is going to help them realize that it's not a witch hunt. We're not trying to embarrass anybody when we do pen tests. We're here to help out. It's going to make the test way more efficient. And then lastly, be ready for the pen test, have the test environment ready, have test accounts to go on day number 1. That is the most important thing. And it's so frustrating to see clients waste their time and money whenever it's day 1, we're starting the test and we still don't have test accounts. We're literally sitting there with nothing to do. So that's the main thing I'll say on that. And moving along, since we're short on time, I won't really talk about bug bounties, but it's kind of it's worthy of its own talk. There's some benefit. There's definitely benefit to it, but at the same time, be ready to handle the amount of reports you're going to get. A lot of them are going to be bogus reports, but there's definitely benefit to it because it can save a lot of money. And I think that was within the last minute. We don't have time for questions, but I'd be happy to talk to anybody that is interested in pen testing. I've done everything from AppSec to red teaming. My slides are in this QR code as well as my contact info. And these are some different links of things that I like and support. LastCon, besides DFW are great. And Juice Shop at the top left corner, if you're interested in AppSec, is a great OWASP tool to check out, or vulnerable application to check out. But thank you, everybody. Sorry for having to speed through this, but appreciate the time.
Round of applause in the room, Gabe. Good job. Thank you.
Thanks.
All right, thanks everybody for coming out. That concludes the night of security. Thank you so much.